Welcome to this lecture on process control, chapter 2, Laplace transform, part 16. So in the previous parts, we have been finding the inverse Laplace transform of some functions. We have found already for about 5 functions, and today we'll find the inverse of 2 more functions. As I said earlier, these functions and their inverse will be very useful in the study of process dynamics. And in this class, you will find the inverse of this function, f of s equal to 1 by tau s plus 1 whole square. So this is just right, only one term in the denominator. If you write this, taking tau square common out, here I take tau square common out. Take tau square out, so this becomes s plus 1 by tau whole square. So this is of the form, excluding tau square, it is 1 by s plus c whole square form. And L of Laplace of t into e power minus at is known as translation of transform. So L of t into e power minus at is 1 by s plus a whole square. So here a is 1 by tau. So using this rule, the inverse of this, so when you take inverse of this, the inverse of 1 by tau square into s plus 1 by tau whole square using this formula is 1 by tau square. This tau square is as such. This is going to be t into e power minus t by tau. T into e power minus t by tau. So if we rearrange this, I take same. Take t here, t by tau square into e power minus t by tau. So this is the inverse of the given function. So this is the inverse of the given function. Given function is this. So inverse of 1 by tau s plus 1 whole square is t by tau square into e power minus t by tau. So next we will see this function f of s equal to 1 by s into tau s plus 1 whole square. So the difference between this and the previous function is there is an s term. S term is added in the denominator. Okay. So we'll do this by splitting into partial fraction. So there will be there are three factors in denominator, s and tau s plus 1 whole square. Tau s plus 1 is repeated 2 times. So there will be 3 factors. So let us split this into 3 factors, a by s plus b by tau s plus 1 and c by tau s plus 1 whole square. So next I take an LCM. Multiply the throughout by LCM, so it is going to be 1 equal to left hand side 1 equal to a into tau s plus 1 whole square plus bs into tau s plus 1 plus cs. So let us evaluate the constants a, b, c. So let me substitute. First is simple, let me put s equal to 0. So if we put s equal to 0, this term goes and this term goes. So you're left with only a term, so that going to give me 1 equal to a. That is a equal to 1. Okay. So next what do we do? So next let us substitute s equal to minus 1 by tau. So we put s equal to minus 1 by tau. Tau s plus 1 is going to become 0. So this term will be 0, tau s plus 1, and here also will be 0. So you're going to get 1 equal to minus c into c minus c by tau. So this means c equal to minus tau. So you got a is 1 and c as minus tau. We're going to get b. So compare so left hand side s square is 0, right hand side you have a into here, this term a into tau square, and here b into tau. So a tau square plus b tau equal to 0, and already a is 1, so b is going to be a is 1, so tau square plus b tau equal to 0, so b equal to minus tau, so b is going to be minus tau. So b is minus tau, c is also minus tau, and a is 1. So let me substitute all these things in the term in this. So after substituting a, b and c, you get this f of s equal to 1 by s. This is for a term. Second term is b is minus tau, so minus tau by tau s plus 1. C is also minus tau, so this should be tau square. So this is c, so this is c term. C is, this must be tau square only, so it's a tau only, no tau square here, this must be tau. So this should be tau only, not tau square. Okay, 1 minute, I'll correct this. So the third term is c by tau s plus 1 whole square. C is minus tau, so minus tau by tau s plus 1 whole square. Now let us take the inverse of this, inverse Laplace. So if you take inverse f of t, 1 by s we know it is 1, and tau minus tau s, 1 by tau s plus 1, we have found it earlier as 1 by tau into e power minus t by tau. So this is the inverse of this term. 1 by tau s plus 1 is 1 by tau in e power minus t by tau. We have found it earlier, the previous lecture. And this minus tau into this, just now in the beginning we found 1 by tau s plus 1 whole square. 1 by tau s plus 1 whole square is t by tau square d power minus t by tau. So this is the inverse of this, which was found in the beginning of this class. So if we simplify this, we'll get the final answer. So if we simplify this, tau and tau cancels, you get e power minus t by tau. Here tau and tau square, 1 tau goes, t by tau into e power minus t by tau. So I take an e power minus t by tau common here, so remaining terms is minus also common, so 1 plus t by tau. So this is the inverse of the required inverse of the given function. What's the given function? F of s equal to 1 by s tau s plus 1 whole square. So the inverse of this function is this. Well, so these functions and the inverse will be useful later on, the study of process dynamics. Now I'll give you one more function as an exercise for you to find the inverse. So next I'll give you an exercise. Do this as an exercise. Try to find the inverse of f of s equal to 1 by s square into tau s plus 1 whole square. There is additional s here, one more s in the denominator. So first we saw 1 by tau s plus 1 whole square. Next with one additional s. Next this s square, another s in the denominator. So try to find the inverse of this. We will see in the next class, next lecture. See you.